Hello everyone, my name is Elsa Milianto and I'm here to discuss to you the directed graph. So first things first, what is directed graph? So directed graph in which edges represents directions is called graph. And the directed graph uses arrows instead of lines or edges. So in simple terms, a directed graph is a type of graph where edges have a specific directions. Think of it as a roadmap which arrows pointing the way. Unlike a directed graph where edges simply connected nodes, in directed graph, these edges have a clear sense of directions. As you can see in this example, the arrows indicate the flow or directions between nodes. It's like following a set of paths from one node to another. This concept is powerful because it models the relationship with a clear sense of order. Now, graph is that edges can represent one-way or two-way relationships. So this is the one-way and this is the two-way. This is the examples of two-way. In some cases, you can only move in one direction along an edges, while in others, you can go back and forth between nodes. So now, I'm going to discuss to you on how to implement directed graph. So first things first, we need to create or import the java.utility. So we'll know that this asterisk represents all the classes. So including the array list, which is class that we need in creating or implementing directed graph. So here we need to create a class name edge that stores the edges of our graph. Here, after creating a edge class, we need to declare a variable which represents our source and our destinations for our vertices. So here S represents our source, D represents our destinations. So we need to create a constructor for our class edge. So this one is constructor and has a parameter S and our source and D. So inside of our constructor, we need to assign the value of S to the instance variable S, and we need to assign the value of parameter D to the instance variable D. So after creating a class edge and constructor of the class edge, we need also to create a class that represents our graph object. So here we created a class graph. So inside of this, we created a adjacency list. So adjacency list. So this one is something called the list of lists. So list, this one here, the outer list represents a list where each element is another list. So here, the inner list, which is here, this one, represents a list of integers where in the context of an adjacent list typically represents the neighborhood of vertex in a graph. This one is essentially a collection of lists where each inner list corresponds to a vertex in a graph, and the integer within each inner list represents the neighborhood of that vertex. So after that, creating, we need to create a constructor for a class. So this is our constructor of our class. here. So this is no constructor for our graph rather. This graph takes a list of edges as inputs to construct the graph. Here we initialize to n to 0. This one will take or get the maximum number or the maximum vertex number for each loop, that this one which iterates over the edges. So this one iterates the over the edges in the given list of edge in the given list of edges. So here, this determines the maximum number of vertex. This one updating this n to store the maximum vertex number encountered. So we all know that this one is already a built-in, which takes the maximum number. For loop, which iterates from 0 to the number of vertex or vertex number. This one iterates. Then inside of it, we added a an empty list for each vertex in the adjacency list. This one. And this one adds the edges to the undirected graph. This loop through each edge is the given list of edges again. So it will get the current S, which is our source, and add the current destinations. So functions to print the adjacency list representations of our graph. So this one's basically print all the adjacency list representations of our graph. So here we created a method. This one is a method one. And inside of our method, we initialize this s to 0. So this one represents our current source vertex. So here we determine the size of our adjacency list. So this one size. So this is our you can determine that this one takes the size of a adjacency list because of this method, built-in method size, which takes the size or the numbers of our adjacency list. So this iterates through each vertex and then print the neighborhood vertices including the current vertex here. So int dgraph, this is we use this for loops to print the adjacency list for the graph. So this one, so I wait. So sorry. So this one looks what it were wait. What on niya is to look through the neighbors of the current vertex. And this is the follow. This is its function, and then it will print the edge between the current the current source here and the destination vertices here. So it would basically like, for example, you have source 1 and destinations 2. So it's like pointing the arrow is pointing to 2. But you will see the output of this problem. So we all know that we all know the function of this one. So the cursors will move next to the line, sorry. Then it will increment the source by 1. So this one iterates until the size of our adjacent list. So here in our main, which is the starting point of our program or the entry point of our program, um, yeah, this is the starting point of our program. We created a list of edges and initialize it. We initialize it new. So we created a new edge 0, 1, 1, 2, 2, 4, 4, 1, 2, 3, 2, 2, 5, 3, 4, 5, 4, 1, 1. So the first number here represents our source, and the second number represents our destination. So here, this is our graph list. So we created a graph using the list of edges here. So this is our list of edges here. Kani. And then if this one is not called but trigger ba kani siya, this one it will kani siya mo trigger ni siya. This is going to trigger. If this trigger, it will here it will perform of list edges. It will perform here and will take the edges list of our edges, since this is our object. So it will carry these new edges, carry this as D, and it will and bring it here in our here. Basta ma-trigger na siya, basta makuha ni siya diri, mabasa ni siya diri. And then after that, this graph one, yun, ma-trigger siya ni with a list of edges. So this one, it will what do you it will carry all the edges, list of edges, and yeah. Kani siya ma-trigger sa ni siya. Then, and then it will carry this list of edges here. Here, by the way, here. And then after performing here, after performing or executing here, it will go back to the main method, and we call our method show graph method, and it will carries, so it carries the graph, which is our here graph. It carries all our list of our edges here, this one, and print all here. It will print all our adjacency lists for our graph. So if you execute this one, it will have an output like this. See, adjacency list for the graphs through 1, 0 is pointing to 1, 0 is our source, 1 is our destination, and so on and so forth. Again, that's it for today. I hope you understand my explanation, and I hope you enjoy this video. See you guys soon. Bye bye.